Okay, so let's talk about matrices. And the first thing that we need to understand with matrices is there's certain rules that you have to follow with them, and certain things that you can do with them, and certain things that you can't. So that's going to be something that we want to make sure that we talk about today. Right, so with matrices, so let's talk about kind of these matrix rules, first of all, right, things that you can do. So one thing that we can do with matrices is that we can switch any two rows. Right, so remember rows go across, columns go up and down, so you can't switch columns, but you can switch the rows. All right, then another thing that you can do is that you can add one row to another row. Then you could multiply the row by any number except 0. Because if we multiply by 0, we just get zeros all the way across, so that doesn't really help us.
So I had a question about that. So if you had like a 4 and you're trying to get a 1 in the first spot, and you decided to multiply the whole row by 4, you could do that to get the 1 in the first spot, like it's the first row, correct? Or no?
Trying to make sure I'm understanding. You can multiply by anything. So as long as it's the whole row, though, you can't just multiply one of the things by it. But if you could multiply the whole row by 4. Is that what you mean?
Yeah, it's just I was doing that yesterday, and there's like so a row started with 4, and you have to get a 1 in the first one, and the bottom one you have to get a 0. And when I multiplied the whole row by it was 4, and like somehow I got it wrong. And it was frustrating.
Okay. Yeah, we'll talk about it today, so hopefully you can see maybe. If you've had a little bit of, practice trying to figure these out, I think actually today will be a lot, you'll kind of go, oh, okay, I see what I was doing there. All right, and then the last thing that you can do is kind of a combination between Rule 2 and Rule 3. So you'll multiply a row by a number and then add it to another row. So I'm just going to put combo. Yes.
Are you meaning to share your screen?
I am meaning to share it. Thank you. Oh my goodness, what a day. There we go. Is that better? All right. Thank you so much. I didn't even notice I wasn't sharing it, so that makes it a little bit hard. All right, so when we do, so we can do any of these 4 things. And then there's kind of, so an augmented matrix, right? And you'll hear that word. Is just when you're taking like equations and you're changing them to matrix form, right? So on some of the homework problems, it just says change these equations to an augmented matrix, but it doesn't tell you to solve it or anything. It just wants you to change it to an augmented matrix. So make sure you're noticing, because some students are doing more work than they have to. On some of them it'll ask you to solve it, but some it just wants you to change it. And that's basically just taking it, if we had 3x plus 4y equals 7, and then maybe negative 2x plus y equals negative 1, right? Then when we're changing this to an augmented matrix, you first of all need to make sure that your equations are in standard form, right? So they have to both be in that form of ax plus by equals c. So where your x's and y's are on the left side of the equation and your whole numbers are on the other side, right? So if it's not in that form to start off with, you've got to move your equations around to get them in that form first, right? So make sure that's a huge thing to make sure you're doing before you start solving any matrix. So then the augmented matrix for this one, right, would just be, on the top row, we're just looking at the coefficient. So we'll have 3, 4, and then 7. Usually I put just a little line here to help me, remember that, over here, right, on the right-hand side is where my answers are going to end up after I solve the matrix. Okay, and then on the bottom row, I'd have -2, 1, and -1. Okay, and then you'd be able to take it from there to solve it. Okay, so then the other thing that you kind of need to know about matrices before we can kind of get into it too much here is that when you have, right, matrix, we're trying to get it in the form. So on the right-hand side, it says 1, 0, 0, 1, right? So it needs to look like this. And once it's in that form, this will be our x value, and the number here will be our y value. Right? So we're solving these still to try and find x and y. We're trying to find the point in which these two lines are intersecting each other. So a matrix is just another way to solve these. So we've talked about we could solve them by graphing, we could solve by substitution, by elimination, right? But we can also use matrices. And matrices are actually really nice when you have a lot of different variables, right? So, I mean, we're not going to solve anything in this class but 2 by 2 matrices, but in 1050 you'll talk about how to solve a 3 by 3 matrix. There is one question on the homework, and I'll talk about that, where it tells you to take a 3 by 3 and solve it using matrices. But I'm not going to be testing you on that. It's not going to show up on a test or the final exam. It's more of what you're going to be learning in 1050. So we just are kind of, short on time, and I just don't feel like it does any justice to be able to get that started, because it is quite a process being able to do that. And it's not like you're going to be behind in 1050 if you haven't done that. Okay, so don't want you to worry about that. All right, I forgot I didn't open this up. All right. So yeah, so remember, I am recording this, so if for some reason you guys are having any kind of issues with your internet or with your power and stuff like that right now, and it keeps like cutting out or something, I will record it and post it later so you can watch it when it's a better time for you. Okay, but we are going to be talking about the car comparison project today, and so I do want to make sure, I hope a lot of you will be able to be here today when we talk about that. Okay, and so the other thing with matrices that I wanted to talk about, and it's not really talked about a lot like in the videos, or I don't hear a lot of other instructors talk about it, but there's a mapping, like how to do this. And like I said, they're not going to follow it on all of the videos that you'll see, but I'm just wanting to let you know that if you start with the upper left-hand corner, make that a 1, move down, make that bottom left-hand corner a 0, then move over, get the bottom right-hand corner to be a 1, and then go up to get the upper right-hand corner to be a 0. So if you go in this way, right, this little mapping, then it will actually make it faster for you, because those of you that maybe have practiced a little bit may have found that you went and made some 1s and 0s, and then on the next step, those 1s and 0s like turn into different numbers, and you're like, I want to pull my hair out, right? Because that can be kind of, nerve-wracking. But if you follow this little mapping, then that won't happen. Okay, you won't be like making it, 1 or 0 and then changing it back and then go, okay, now I have to change it back to a 1 or a 0. So this just makes it a little bit easier. So when we work through it, this is the mapping that I'm going to follow on here. Okay, like I said, not a lot of the videos, they don't do it that way, but I know when you're starting just to learn matrices, it's a little bit easier to follow this. It's not like you have to follow this, right? You can do it other ways, but it does make it less frustrating. So, all right, let's take a look at some matrices and how we're going to solve some of these. Let me see here. I opened up to the wrong page. A second. All right, so let's try this one. So here's first example. All right, so solve using matrices. And here are my equations. So I have 3x minus y equals 5, and then x plus 2y equals 11. Okay. So let's first write it as an augmented matrix. So across the top I'll have 3, -1, be really careful, right, to make sure that your signs are what they should be. So 3, -1, then 5, and on the bottom 1, 2, and 11. Okay. And then again, before maybe we figure this one out, I want to tell you 2 more things about matrices. Okay, so if you're trying to make zeros, okay, well, actually, let's do make ones first. So those are the 2 things that you're trying to make, right? You're trying to make ones and you're trying to make zeros. To make ones, the easiest way to go about that is to multiply by the reciprocal. Right? So that will always work, multiplying by the reciprocal, right? But sometimes we could switch the rows if we see there's already a 1 in the other one. Okay, so we could multiply by the reciprocal, we could switch rows. Okay, to make zeros, right, the way that this works is, I mean, you could add one row to the other. Or you can do that combo thing that we talked about, that rule number 4, where you do a combo of 2 and 3, where you multiply by something and add it. Okay, so I'm just going to put here like rule number 4. Right, and we have up here, right? So that combo. So let's let's think about this, and how we're going to make ones and zeros with this one. So first place we're going to start, remember, is the upper left-hand corner. We want that to be a 1. So what do you think would be a good way to get a 1 here where that 3 is? Any ideas? Okay, you could multiply by 1/3 because that's the reciprocal, but do you see that is going to give you some kind of crazy fractions that you might not want to have to deal with? But you definitely could do that, right? Multiply by the reciprocal. There. Does anybody see anything else that we might be able to do?
We could flip those 2.
Yeah, we can just switch any 2 rows, right? That rule number 1. If we switch these, right, then we're going to have a 1 up there in the place that we want it in. So that's probably what I would do, so I didn't have to make fractions or work with fractions, but both ways will totally work. Okay, so we'll have on the top now 1, 2, and 11, right? Everything that was on the bottom row is now on the top, and then 3, -1, and 5 is now on the bottom. All right, so now what? Now we want to make this 3 on the bottom into a 0. Because remember, we're going to kind of go down this way. All right, so we made it 1. Now we're going to make this one into a 0. How could I make that 3 into a 0?
multiply the 1 on the top by -3.
Okay, so if we do -3, right, so we're looking at what's the opposite of this number. So it was 3, so I'm going to multiply that top row by -3. So I'm going to do -3 times row 1, but then I need to add it to row 2. Okay, and this is where some students get a little bit confused. Okay, whenever you're adding rows together, the only row that changes is the row that you're adding to. Right? So in this case, row 1 is not going to change when I write down my matrices. So I'm going to keep that. So since I don't want that to change and I want to remember that's going to stay this way. So I'm going to put 1, 2, and 11 here because I've got to remember only row 2 is what's changing. Okay, and then I'm going to do a little bit of work out here to the side because I know sometimes it gets a little bit confusing, for students when they're first seeing this, like, what are we doing? So we're taking -3, multiplying it by the top row. So if I do that, -3 times 1 is -3, -3 times 2 is -6, and -3 times 11 is -33. Right? So I just multiplied that -3 through, kind of distributed it through. And now I need to add it to row 2. So underneath here, I'm going to put my row 2. So 3, -1, and 5. And then I'll add these guys together. All right? And that's going to be what my new second row is going to be after I add these together. So I get 0, -7, and -28. Right, so then on the bottom row, that's what I'm going to put here. So 0, -7, -28. Okay, so let me stop right there for a second, make sure everybody's with me. What questions do you have here so far? Okay, so we made the 1, we made the 0. Now we need to make a 1 in the bottom right-hand corner. So how can I make that -7 into a 1? How would we do that, Gabby?
Wouldn't you multiply by +1/7?
Not positive, but negative.
Oh, just
right?
-1/7. Yeah.
Yep, because a negative times a negative is going to give us a positive. So we'll always keep that sign the same, but multiply by the reciprocal, right? So yeah, so -1/7 times row 2. And so this is kind of something else with matrices that sometimes students get a little bit confused by, is you'll see, in the things that we can do, we can multiply and we can add, but it never says anything about division or subtraction. So really those things aren't technically legal, to do subtraction or division, but you can think about it that way because I know sometimes students are thinking, it's hard for me to think about multiplying by -1/7, but if you just thought, oh, I'm dividing by -7, right, on that bottom row, that makes it a little bit easier. Okay, so remember just row 2 is changing, so our row 1 is still going to be 1, 2, and 11. And now on the bottom, right, so -1/7 times 0 is just 0. -1/7 times -1/7 times -7 is a +1, or just think of it as -7 divided by -7. Right, and then -28 divided by -7 would be a +4. Okay. All right, we're almost there. Now we just need to make this 2 into a 0. So how could we go about making that 2 into a 0?
Would you multiply the second row by -2 and then add the first 2 rows together?
Exactly, right? So again, you're looking at and saying, okay, what is the opposite of this number, right? So opposite of 2 is -2. We'll multiply that by row 2, right? Because that would give me a -2 here. And then when I add it to +2, that's going to give me a 0. Okay? So Shayla asked, can I use division with -7? And I mean, technically you're not supposed to divide with matrices, and you'll kind of see, you'll talk about it more in 1050, why that's not, you know, like a technical operation and stuff like this. But for this, in this context, it's just fine in your mind just to think about dividing by -7. That's totally fine. If that's easier for your brain to do, just you can think about it that way. Okay? But you'll talk about it more in 1050, why that's not really the most correct thing to say. Okay? All right. And then let's do that here. So I'll just do a little bit of workout to the side. So remember, I'm going to take -2 and distribute it through row 2. So that's going to give me -2 times 0, 0. -2 times 1 is -2. -2 times 4 is -8. And then I'm going to add my row 1 to it. So just like it is there, when I add those together, I get 1, 0, and +3. Right? And so that's going to be my new row 1. Right? So row 2 stayed the same, but row 1 is now 1, 0, and 3. Okay, so now that I have my left-hand side that looks that way that I need it, then I can see what my X and Y are. And I'm still finding a point. So oftentimes it'll ask you to write your answer as an ordered pair, because 3, 4 is the point in which these two lines would intersect each other. Okay? All right, questions on that? And remember, you don't have to show this work out to the side. Some of you can do it in your mind and stuff, and that's totally fine if you can. But I think for a lot of students starting off, this might be an easier way to go, because it's really easy just to mess up by a negative or something, and that throws the whole thing off, and then you can't find where you made a mistake, and so then you have to start it over again. So yeah, so I encourage you to, write it out if you're feeling like, yeah, I think, negatives kind of give me problems and stuff, a lot of things. Okay, let's try another one. And oopsie. So remember when you're trying to solve, whoops. Goodness. So I want you guys to set this up first before we start solving it. Let's make sure that you have it figured out. Okay, so in this one, we've got y equals x plus 2, and y equals -1/2 x minus 1. Okay, so what do I need to do first here?
Would you want to get the x's and y's on the same side?
Yes, awesome. That's exactly right. So we can't set it up in a matrix form unless it's in that standard form, right? So I need to subtract my x over here, and so then that means my equation will look like -x plus y equals 2. And then my other one, I need to add 1/2 x over. And so then that would give me 1/2 x plus y equals -1. All right, so now, right, we can change it to matrix form. So let's do that. So I get -1, 1, and then 2. And on the bottom, I have 1/2, 1, and -1. Okay, so where do you think would be a good place to start? A couple of different places you could start. So somebody said with the -1, all right, so you could multiply that top row by a -1 to make it a 1. I do notice that there's a fraction on the bottom, and usually I'm not so keyed about having fractions, and so I might start by, killing off the denominator, so multiplying that second row by 2 and then go from there. But either place is a totally good place to start. I just don't like dealing with fractions if I don't have to on matrices because it's just easy to make mistakes with them. So I'm going to do +2 times row 2, right? Because 2 times 1/2 is going to give me a 1 there, and I'll get rid of that fraction. So my top row stays the same, -1, 1, 2, and my bottom row is now going to be 1, 2, -2. I'm just distributing a 2 through row 2. Okay. All right, so now at this point you can either, multiply the top row by a -1, or you could switch your two rows because there's already a 1 there on the bottom. So either way would be a good next step. So you got to see that there's going to be more than one right way to do these. Okay, so I'm going to actually switch the rows. But it's up to you. You'll see in the end, you'll still get the same thing, okay, even if you go about it differently than I did. All right, so I have 1, 2, and -2 on the top, and then -1, 1, and 2 on the bottom. Okay, so now I have my 1 in the upper left-hand corner. Now I want to get a 0 in the bottom left-hand corner. How could I get that? Anybody have a suggestion? Awesome. Yeah, Trevor said add the top row to the second row. Right? So if I do that, if I'm going to add these guys together, and remember, I'm trying to make a 0 on the bottom, so I'm doing row 1 plus row 2, because whatever row I'm adding to is the one that's changing. Right? So my row 1 is still staying the same. 1, 2, -2. But when I add these rows together now, right, 1 minus 1 is 0, 2 plus 1 is 3, and -2 plus 2 is 0. Okay, now what would a good next step be? Right, so we've got a 1, 0, so now we need to get this 3 to be a 1. How are we going to make 1s?
We can multiply row 2 by 1/3.
Yeah, so let's just multiply by the reciprocal, right? Because that's an easy way to make 1s for us. So yeah, so let's do 1/3, so that's the reciprocal of 3, times by row 2. Right, so again, my row 1 is not changing. Right, so I have 1, 2, -2, and then if I multiply by 1/3, or you can think about it as dividing by 3, right, I get 0, 1, and then 0. Okay, now I just have one more step to take. I need to get that 2 in the upper right-hand corner to be a 0. How should I go about that?
Multiply row 2 by a -2.
Okay, and then do what with it?
And then you add that by row 1.
Yeah, and then add it to row 1, right? So this time row 1 is what's changing, right? So my row 2 is going to stay the same, so I'm going to just write it down so I don't forget. So I've got 0, 1, and 0. And then I can do a little bit of work out here to the side if it's a little bit easier to see. So -2 times row 2. Well, -2 times 0, 0. -2 times 1 is -2. -2 times 0 is 0. And then now I need to add row 1 to it. So I'm just going to put row 1 underneath there. And then I'll add these together. So I'll have 1, 0, and -2. And that's what's going to go on my top row there. All right, so 1, 0, -2. Okay, and now I have it in the form that I need it in, and so I can see my two answers, right, what my x and my y are. So the point in which these two lines intersect is at -2, 0. Right, so my x is -2, my y is 0. Okay. All right, how are you feeling about this? You kind of seeing what you need to do? I know it takes a lot of practice, it really does, you know, but once you kind of practice it some, you're like, okay. And I think just understanding, you know, like kind of this mapping that we talked about, it's really helpful. And then also just if you're thinking about, okay, what's the best way to make ones? What's the best way to make zeros? All right, just understanding those few things can really make a big difference in making these matrices easier for you to do. Okay. All right, let's look at, I think it was number 9 is what somebody wanted to look at on the homework. So let's do that. Let's see here. So 2.4, 9. Okay, so maybe before we do that, notice these are the ones that I was talking about. So write the system of equations as an augmented matrix. So it's not asking you to solve anything there. It's just saying take those coefficients and write them in matrix form. Okay, so don't overthink those. A lot of people miss them because they're trying to solve it, but it's not asking you to solve it on those. Okay, and down here is where it's asking you to solve it. They put it in the augmented matrix form, but now they're saying solve it using matrices. Okay, and then on this one, write it as an augmented matrix, right? So just put those coefficients in there and then solve. So just your solution will be in here. All right, so on that one you're doing both, but you're not writing this up here as 1, 0, 0, 1, and then the two answers. Okay, you're just writing them just like they are written there. Okay, so number 9. So on number 9, this is one of those ones that I was talking about, and we're not going to use matrices on this, okay? I just want you to solve this in the same way that we did in 2.3. When you get into 1050, you'll talk about how to solve using the matrices with that. And I mean, I'll just kind of point out, because some people might want to try it, you know, using matrices, but I'm not going to spend time doing it since this is not going to be something that you're going to have to, you know how to do. But the mapping for a 3x3, right? Some of you might be wondering, well, what would be the best way, you know, to go about this one? Well, so let me write these in here. So this is what you want the left side of it to look like, right? So 1, 0, 0, then 0, 1, 0, and 0, 0, 1. And then when you solve it, you'll have your x, your y, and your z. Right? So you'll be able to find those answers there. Okay, and then the mapping for this, right? So on the other one, you're just kind of making a U shape, kind of going around. But this one you have to do a little bit different. So we'll still start with that 1 in the upper left-hand corner, then go down and get both of those zeros. Okay, then you're going to kind of do a little diagonal thing, go back up and get that middle 1, right? And then we'll go down and get that 0, and then we'll kind of go up and around. Okay, so this one has a lot more steps to it, obviously, because there's more that we have to find here, right? But, you know, if you want to try it out and see if you can, you know, solve that one using matrices, remember I'm saying you don't have to do that. But if you're like, oh, I want to get like maybe a little bit ahead and see if I can do it, then go ahead and try it out. But if not, you know, like you can still, you know, I'm just saying solve it using the same way we did in 2.3 with the 3 equations, 3 variables, where you're just using that elimination method to do that. Okay, does that make sense there? What you need to do. And then notice on question 8 too, like, so some of these it's just the question. Sometimes people are like, what do they want me to do? So now you're just taking your augmented matrix and writing it back in equation form, right? So it's like you're undoing that, writing it back in that form. And on this one, it's just write it down as an augmented matrix, okay? But when it says find the reduced row echelon form, that means that you are solving it. And so on this one, you will be putting, you know, you want it to look like the 1, 0, 0, 1, and then what your 2 answers are over there. Okay. So I know some of the questions, just sometimes people are like, what is it that they want me to do? And sometimes if you watch the little videos that's right with them, sometimes they're helpful to be able to see how it wants it written, but sometimes not. I know some of the videos aren't always the best. Okay. All right, what other things can I help you understand better? All right, so Chris is saying he feels like he's got it now. He tried to figure it out yesterday on his own, and it was hard, but it looks like he's feeling good about it now. Okay. But so somebody else asked about in 2.3, there was a question, you know, solving like a 3 by 3, and they used a matrix to solve it, even though you hadn't learned about matrices yet. You don't need to do it that way. But remember, make sure that you look back at, you know, some of the announcements that I posted, because I posted some things there to help you with some of those questions. Let's see. Let's see here. So there, yeah. So videos for 2.3 and 2.4. Okay, so please, you know, if you're struggling with some of the things on there, I made some videos that I think will be really helpful for you in figuring out some of those questions. So look there. And again, like on the one where there's infinite solutions, right? And it wants you to find it in the parameters, like, so like solve it in terms of z or something like that, right? There's, let's see, put that one here. I thought I put that one on here. Maybe I need to still put that one. Did any of you find that 3 by 3 matrices where it was, or 3 by 3 is where you had to solve for it? Let's see. Sorry, I thought I had that posted there. Maybe I posted it as a different announcement. Oh yeah, it's this one right here, the infinite solutions one. So there was 2 different announcements that I did that had some videos in them. So check those out if you're struggling when you're looking at that one with the infinite solutions, because it is kind of weird, but I think that video you'll find will be really helpful in being able to figure out what you need to do there. Okay. And just know on that infinite solutions one, again, that's more of the scope of 1050. I'm not going to be testing you on that. If you can write it, in the parameters and, you know, in terms of z or anything like that. So, I mean, we could work through one if you wanted to, but I would rather kind of do that at the end of class for those that want to do that. Since, like I said, it's not going to be something that will, you know, that I'll be testing you on or anything. So, but some of you are still wondering how to do it. So if you want to stick around at the end of class, and I'll go through that one with you. So then that way you can ask me some questions if you have some questions that come up. Okay. All right, we're going to talk also about 3.1 today, and then we are going to be dealing with, you know, start talking about the project that we're going to be doing. It's a car comparison project, and so we'll start that today in class. And so let's, first of all, let's see. Somebody else had another. Oh yeah, the 3 different acid solutions. Maybe I'll work through that one really quick too, because I think that was on. Is that on 2.3, Sheila, or was that 2.4? I can't remember which section that was in. All right. So let's look at one like that. Let's do. We did this one in class last time, but maybe we didn't make it to it. Did we do this one last time? The chemist has 3 different acid solutions. Anybody remember? No, we didn't. Okay. I meant to. We must have just not had enough time for it. So, all right, so let's do this one then together, right? So a chemist has 3 different acid solutions. The first acid solution contains 20% acid, the second contains 35% acid, and the third one contains 75%. He wants to use all 3 solutions to obtain a mixture of 198 liters containing 30% acid, using 3 times as much of the 75% solution as the 35% solution. So it sounds like the chemist has a lot more of the 75% solution, so that's why it's wanting to use 3 times as much of that. Okay, then how many liters of each solution should be used? Okay, so with this one, right, just like we did before with these mixture problems, we set up a little table. So I'm going to do that first. And you don't have to set it up as a table, right? But yeah, so this is homework 2.3. I was asking number 8. Okay. So remember that the things that you're mixing together need to be along the top. And then any of your labels or units of measurement that you come across is going to kind of go along this side here, right? Just to help you figure out how to set up this chart. So what are the things we're mixing? Well, we're mixing a 20% solution, we're mixing a 35% solution, 75%, and we want to end up with a 30% solution, right? So that's what my total needs to be, is a 30%. 30 looks weird. All right, so so this kind of brings me to the point when we're looking at the bottom here, right? The 3 things that I'm trying to find is how many liters of the 20%, how many liters of the 35%, and how many liters of the 75% solution. So that's what I'm going to call my X, Y, and Z. So I'm going to say X put it up here a little bit. So X is going to be the amount of 20% solution. Y is going to represent the amount of 35% solution. And Z will represent the amount of 75% solution. Okay, those are the three things that we're finding. So so I need to make sure that I have the three variables listed there. Okay. All right, and then the units in here, well, it looks like I'm dealing with liters. So that's going to be one of my lines. It's going to tell me stuff about the liters. The second one is the percent. All right, it's giving me things about percent. And then about the total. Okay, that's what I'm going to be dealing with here. And then, so we're not going to get to that, the sentence that says using 3 times as much of the 75% solution. That's not going to go in this chart. We're going to determine that in a little bit. But we got to find our first two equations by using this chart. Right? So I don't know how much of the 20% I need in liters. So I'm going to call that X. I don't know how many liters of the 35% I need, or how many liters of the 75% solution I need. Okay, but I do know I need a total of 198 liters, right? That's what it gives me there in the question. So that's going to be 198, the total, right? All right, and then in the second row, this is my percentages. So that's basically just where I'm changing my percent to a decimal, right? So remember, to change a percent to a decimal, I'm just moving that decimal point back 2 places, right? So I have 0.2, 0.35, and 0.75. And then I need it to end up being a 30% solution, so I also need to put that here, so 0.3. Okay? And then my last one, so yeah, that first equation, right, is just found by that top row. It was saying that. So X plus Y plus Z equals 198. And then my second equation is found by multiplying those 2 rows together. Right? So I'm going to have 0.2X, 0.35Y, 0.75Z, and then you got to make sure that you're multiplying that 198 times 0.3, right? So 198 times 0.3 is 59.4. Right? And so then that will be my second equation. So 0.2x plus 0.35y plus 0.75z equals 59.4. All right. Is everybody with me there to that point? Being able to set this up. So far, it looks really similar to how we set them up when they were the 2x2s, right? But now we just have one more solution that we're mixing with it, okay? But this next part is different because to make our third equation, we have to use this line that says using 3 times as much of the 75% solution as the 35% solution. So remember, we called the 75% solution Z and the 35% solution Y. So how could I write that as an equation that says that?
Would it be Z equals 3 times Y?
Okay, so let's look at that. So would this be it? Z equals 3 times Y. Okay, so let's just think about it, because sometimes people get confused and they think it might be Y equals 3 times Z. But there's a way you can tell which one is the correct one, right? I mean, just, think about, okay, say that I have, I have 5 liters of the 35% solution. Well, then that means I'd need 15 liters, right, to have 3 times as much of the 75% solution, right? So yeah, so it would have to be this way that you said, because if I did it the other way, right, I'd have 5 equals 3 times z, and so then z would only be 5/3 liter, right? So that wouldn't work. Okay, so you can kind of look at this and be able to see that. Maybe I'll just put this over here too. All right, so we have z equals 3y. Okay, so now, right, just like you did, before, you got to be able to use, some of this to be able to solve the other. Now, notice that in our very last equation that we made, there's no x's there. So it would be easiest for us to look at our first two equations and eliminate the x. So then we just have y's and z's left. So that would be what I would say would be a good first step on this. And so there's a couple of ways you could do this. Sometimes people like multiplying the decimals by powers of 10 so they don't have to deal with the decimals, but I feel like if you're using a calculator, it probably doesn't matter too much if you have that. And other students would just be like, oh no, I'll just multiply the top equation by negative 0.2 and then add it together. All right, so you could do that way also. So I'll write that down here. All right, and so if I multiply that through, right, on that top one I'd have negative 0.2x minus 0.2y plus 0.2z equals, and then 198 times 0.2 is going to give me 39.6. Okay, so if I just multiplied the top by negative 0.2, I can do that, and then I'm going to add it to that second one. So I'm going to put that underneath here. So 0.2x plus 0.35y plus 0.75z equals 59.4. Oh, sorry, it should be a negative there. I did mess up my negative sign right there. Thank you. Maybe I said it, but I wrote it as a plus. I don't know. And then it should be a negative 39.6. Sorry. Yeah, I got to make sure I'm distributing that all through. Okay. So then when you add these together, all right, our x's eliminate, which is what we were trying to have happen here. All right, and so then when I do the negative 0.2 plus the 0.35, all right, I get positive 0.15. Oops, let me write it in black. And then here, all right, when I subtract those, what am I going to get? Is it 0.55? And then add those two together also. I should get 19.8. Okay, so now I have an equation that has just y's and z's, and this third equation just has y's and z's in it. All right, and I already have one of the variables by itself, z is by itself, so do you see how I could use kind of like the substitution method and just say, okay, I'm going to put 3y in place of z in that equation there, right? So when I do that, I have 0.15y plus 0.55 times 3y, and then equals 19.8. And if you really don't like working with decimals, like I said at the beginning here, you could have multiplied this, this row, whoops, they're all by 100 instead, and that, That will make it so you just have whole numbers to deal with instead of these decimals. But if you don't mind working with them, you can just do it this way, right? So that's going to give us plus 1.65 equals 19.8. And then I have to subtract that over. So I get 0.15y equals, all right, so with 18.15. Oops. And then I just need to divide by 0.15.
Hey, Becky.
Yes.
Aren't we multiplying the 0.55 times 3y? Or
Yes. Oh, so where did my y go, huh?
so would it be 1.65y?
It should be. Sorry, I don't know what my issue is today. I'm struggling. Okay, let's try that again, because that's going to change our answer completely. All right, so now we've got to combine these guys together first. Thank you. So it's 0.15 plus 1.65. And so 1.8 equals 19.8. And then, so now we'll divide by 1.8. So that would be 11. Yes, I don't know. Seems like it might be a good idea to change those to whole numbers for me. I can't believe how many mistakes I made there. My decimals. All right, so what did I just find then? So y is 11. So that means that I need 11 liters. Is that what you guys came up with? Of the 35% solution. Okay, is that what you guys got? Now what can I do from there? What can I do with this y equals 11? Yeah, so go back up to this z equals 3y, and now let's just put 11 in place of y there. All right, so we have z equals 3 times 11, so z equals 33. All right, so I found my next one. So that means I need 33 liters of my 75% solution. All right, then how do I figure out what x is? Awesome, Trevor says just put it back into that original equation here, right? The x plus y plus z equals 198, and we'll put in the things that we know. So we don't know what x is. All right, so x plus 11 plus 33 equals 198. All right, so x plus 44 equals 198. And then let's subtract the 44 over. So x equals, here, 154. 154 liters of the 20% solution. All right, and then just make sure, remember, those should all add up to be, all right, when you add all of those together, 154 plus 11 plus 33, they better add up to be that 198. All right, so that's what I'm trying to find there. Okay. So it is pretty similar to what we talked about before. It's just this last equation, that z equals 3y. You just got to be, careful with to make sure you write that down the way it is asking for there, because sometimes that's easy to get flipped around in people's minds. Okay. All right, I think this would be a good time to take a little 5-minute break, and then we'll come back. 3.1, you'll be happy to know, is not as intensive as, as a homework set to do, and then we'll also talk about the project, the first project that we're going to do. Okay? So let's just take a 5-minute break right now. We'll meet back at 11:08. Okay? Nothing. Just looking at something that should be coming from him soon, or
about 4,000 should be coming soon.
yeah.
But when I send these out, I'll check.
Yeah.
Sending August 10th, so it's going
Yeah. All right, let's get back into this then. So let's move on and talk about some stuff in 3.1. So a lot of 3.1 is going, or a lot of Module 3 is going to be dealing with inequalities. And specifically on 3.1, we're going to talk about solving inequalities and also doing applications with them. Right, so some story problems and stuff with them. So let's first start off. Remember that when we're solving inequalities, we're really solving them very similar way how we do equations. There's just a couple of things we have to remember when we have greater than or less than symbols. So let's just take a look at this one, and this one's kind of involved, but our directions are to solve, graph, and write our answer in interval notation. Okay, and then it gives me something like this. 8x minus 3 times the quantity of 3x plus 12, or plus 2. And then minus 4 is greater than or equal to 3 times the quantity of x plus 4 minus 2x. All right, so we're going to just go about solving this in a very similar way than if it was an equation. So if this said an equal sign here instead of a greater than or equal to. Okay, so the first thing that we'd want to do is distribute to get rid of those parentheses. So let's go ahead and do that first. Right, so on the left side we'd have 8x minus 9x minus 6 and minus 4 is greater than or equal to, now let's distribute that 3 through, so 3x plus 12 minus 2x. Okay, and then we just want to get our like terms together on each side. So when we get those together, we get negative x. When I put these together, I get negative 10. On the other side, I have 3x minus 2x, which is just an x, and then plus 12. Okay, now from here, I want to point something out to you, right? We have x's on both sides, and we could technically move those x's either direction. However, I want to make sure that when you solve these,